Hey guys, welcome. This is our 5.4 video. In this video we're going to be talking about medians and altitudes and where they meet. We talked about this already in our graphic organizer, so we get to kind of speed things up just a tad. So let's go ahead and start. I'll tell you what you need to write down, so just kind of listen to me. But first, the concurrency of medians theorem. This we talked about already in our graphic organizer, so we're not going to write this down again. But the median of triangles are concurrent, meaning they will meet at a point, in this case point C, and it's 2/3 the distance from each vertex. So if you can actually see, let's look at this one right here. FC is going from the vertex to the point of concurrency. This is going to be 2/3 of the entire segment. So kind of makes it easy for us to see how that works. Let's go ahead and take a look at our next piece. Again, you didn't have to write any of this down yet. I'll tell you what you need to write down. Also, congruency of altitudes. All altitudes will meet in a triangle. And then this is the last thing, and I want you to go ahead and write this down, so please write this. I know we kind of already wrote it down, but this will be our first thing that we write down. We have all of our concepts right here. So we have 4 types of concurrency: circumcenter, incenter, centroid, orthocenter, and they're made up of these 4 types of things. So go ahead and pause the video and write those down. Alright, let's look at some examples and we'll get moving right along. Alright, so our first example is to find the median of this picture. So we're looking at this picture and it says XA is 8. What is AB? Okay. Well, as we can look here, we see XA is this segment here, is going from the vertex to, since these are all, looks like medians, because they're going from a vertex to the middle of the opposite side. So we do want to go ahead and write that down. So we are dealing with medians. And since we're dealing with medians, they're going to create our centroid. So this would be a centroid. If I can get it to right. Alright, centroid. Okay. So the distance of XA, and let's go ahead and write this out, the distance of XA is equal to 2/3 of the entire segment XB. Okay? So it's 2/3 of XB. Now we know what A is, or XA is, so it's 8. So this is 8. Now there's 2 ways you can do this. You can think of this logically, and we can add them up. This basically, if this is 8, this is 2/3, this is 1/3, so this is double that. So this would become 4, and you add the whole thing, you get 12. So that's the fast way to do it. That's how I would do it, is that I would say, alright, there you go, it's 12. This is 2/3, this is 1/3, so we wrote down in our graphic organizer, this is double the size. We could algebraically solve doing this, and let's go ahead and just do that real quick, get a little practice with our fractions. So we can go ahead and solve for XB doing this, so let's get this color. To get rid of the fraction here, we can multiply by the reciprocal, and that's going to actually cross cancel. And when we multiply by the reciprocal, we just will go ahead and take care of that over here. And what happens here is we want to multiply straight across, and then we're going to divide, or we can reduce to start. So I'm actually going to reduce. 2 goes into 8 4 times. 4 times 3 is 12. So 12 equals XB. Okay? So make sure you got all that written down, the problem, the picture, and all of our work. But either way we look at this problem, there's 2 methods that we can do it in. We both get 12 equals XB. Alright, let's look at another problem. This one will be a little bit faster. Okay? So go ahead and write down this problem, and we are going to go ahead and determine what segment we're looking at. So PR is right here. So here's PR. We want to know, is this a median or an altitude? Well, the definition of an altitude is that it goes from a vertex and perpendicular to the opposite side. And one of the reasons or things that we talked about is that altitude had to do with height. Okay, and if you recall in class, I want to stand straight up. I don't want to slouch or bend over. when I'm measuring how tall I am, I want to get a perfect height. So this right here is a great representation of height. So in fact, PR is an altitude, okay? It's outside the triangle. Is that okay? Yes, it is okay. We're going to look at that in a second as well. But yes, we can have it outside. But what else do we see here? I see QT, this segment there. That is a median. So QT is a median. So we actually have two things in this picture. From Q to T, it goes from a vertex to the midpoint of one of the sides. So we had both in this picture. It was asking for QR, so our appropriate answer would be altitude. Okay? Let's go ahead and transition real quick. I want to talk about and have you guys write down this piece right here. So go ahead and write all of this down. The orthocenter is lines that contain the altitudes of a triangle. And what's neat about the orthocenter, and this is similar to the circumcenter, is that the position of the orthocenter can be inside, on, or outside of the triangle. So if it's an acute one, we have the orthocenter in the middle, or not in the middle, but inside the triangle, and at right, it's on the triangle. And if it's obtuse, we have it outside of the triangle. So it's really important for us to kind of understand those two different features. Alrighty, let's go ahead and look at our last problem, our final problem. Here we go. Okay, so hopefully you've been saving all your brain juice, because this is probably the most difficult of the problems. But what we're going to do is we're going to find the coordinate of the orthocenter of ABC. So I'm going to try and go through like the logical thought process, and then we're going to go ahead and do the actual mathematical process. So let's go ahead and start here. We have our three vertices, and what I want to do is I want to find the orthocenter. So if you recall, the orthocenter, it has to do with altitude. So we want to find altitude. And in fact, we just have to find two altitudes. So if we can find two altitudes where they meet, we're good. So one of the easiest things to do is looking on the graph is I can go from B and down to AC. And the reason why this works is I'm going from a vertex to the perpendicular of this side. So this right here is a perfect altitude for us. It measures our height of our triangle, and we can use that. For now, the time being, I'm going to erase that line and redraw it without the 90. So we're just going to go ahead and say, all right, here is that line. It's looking good. Now, I need one more, and so this one's a little trickier in how we're going to find. But essentially what we want to do is we want to go from the A or the C, and we want to somehow be perpendicular to this line. Mathematically, we don't know. I'm not sure how we're going to do that yet, but what we're going to do is we're going to do something like this, and we're guessing our point's going to be somewhere around here, potentially 2, 4. So that's what we're thinking is probably going to happen with our answer. Now, this is just eyeballing it. Let's go ahead and be precise. Okay, we have a general idea of what it should be. Now let's actually go ahead and measure it. I'm going to rewrite that. We kind of guessed 2, 4. Let's see how close we are. All right, we're going to walk through this, and here we go. All right, boom. All right, what do we need to know? The coordinates of 3 vertices. We got that. The intersection of the triangle's altitude. We tried doing that. Write the equation of the lines that contain the 2 altitudes. We can solve the systems of equation where 2 lines meet. That's going to be our answer. So that's the actual math we're going to be doing, not what we just did. Okay, so moving forward. Let's see, boom, boom, boom. So which 2 altitudes should we choose? It doesn't matter, but we want to find the easiest ones. So one of the easiest ones for us to find was that vertical. So we drew that same one in. Find the equation of a line containing altitude AC. AC is horizontal, contains it. Perfect, right there. So by the way, what I want you to write down is all the steps. So step 1, you don't have to write these little green boxes, just the steps. So write these steps down. Okay, so there's our step 1. It passes through 2, 7, which is the vertex. So the equation is x equals 2. So we have our first equation. It's a nice vertical line. All right, step 2, we need to find a second line. Once we have 2 lines, then we can use systems of equations. Find the equation of the line containing altitude BC. So here's BC. A is going to go through here, something like that. This kind of looks like what we did. So we first have to find the slope of BC. So here it is them kind of calculating it. and we get the answer of -1. So -1 is the slope. You can actually even count it. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. But they use the slope formula. Okay? Alright, so step 1 done. Moving along. Step 2. And so we know it goes through a point 1, 3. Here's the vertex 1, 3 for A. Put it into point slope form and rewrite it into slope intercept form. Yeah, there we go. Got some math going on. And so we get y equals x plus 2. So we have our two equations, have those written down. Okay, and all this. And we're back. Okay, step 3. Find the orthocenter by solving this system. So I'm going to go ahead and jump in and do this one for us. So we get y equals, so x plus 2, and then we get x equals 2. So this is actually pretty easy. I know what x equals. We know x equals 2. So what I have to do is plug it back in. So we're going to use substitution here. So y equals, oops, mistake there. Y equals, instead of x, we're going to substitute in 2 plus 2, and we get y equals 4. And any luck we do have some luck here. The 2 matches with what we guessed as 2 when we kind of were looking at the picture as kind of making sense, and y is 4, and our y is 4, so it looks like we nailed it. Okay, and so that would be the systematic way of doing it, finding two equations in a line, and then using a systems of equation from algebra to go ahead and solve where it is. So a lot more process in that one. Okay, but I like to map it first, think about it, and then go ahead and do it. So real quick, I have one thing to show you, and I think we're done. This is my puppy. This is Oreo. Say hi, Oreo. Hello. And if you can hear my other dog is whining that she doesn't get to be up here, so I'm going to go get my other dog. So this is Oreo, French Bulldog. My other dog's a little bit bigger, so 1 second. This is my other doggy. Say hello, CB. Say hello. So this is CB, Cuddlebug, as we call her. And she doesn't realize, look over here, look over here, look over here, look over here. No, there's nothing actually over there. Yep. Alright. Oh, I should go full screen. Oh, can you do that? Oh. Okay, that's too much. That is too much. How do we? That is way too much. Too much. Let's just go large window. There we go. Okay. Alright, so that's CD. So, those are my dogs. Peace out.